Often, we can use linear regression to generate predictions for numerical continuous data, such as height, weight, or temperature. But what if you have data that cannot be expressed in numbers, such as color, gender, or job role? In this video, we'll give a brief overview on how to use logistic regression as a machine learning technique for categorical data. Categorical data consists of discrete values that describe an object. For example, the species of an animal. Logistic regression is a great candidate for machine learning problems that involve binary classification, which determines the probability that each data entry can be classified into one of two different categories. Here's an example. Let's say that we have a data set that contains information about different animals, and we are tasked with identifying each animal as either a cat or not a cat. Here's our data set, and let's say that it's filled with some distinguishing features for each animal. Let's say that we have 3 features. We have whether or not the animal has 4 legs, whether or not the animal has whiskers, or whether or not the animal has claws. And finally, since this is a supervised learning approach, we are going to tell the machine learning algorithm whether or not each data entry is a cat or not. Because these are all binary features that can either be yes or no, we're going to fill them in with zeros and ones. 0 means false, and 1 is true. Let's say for the first animal does not have 4 legs. It does not have whiskers, it does not have claws, and it is not a cat. The second animal does have 4 legs, but it does not have whiskers, it does not have claws, and it is not a cat. And the third animal does have 4 legs, it does have whiskers, it does have claws, and it is a cat. So now we have to determine if this machine learning algorithm is able to figure out whether or not each animal is a cat or not a cat based on the probabilities that are generated by logistic regression. Logistic regression uses the sigmoid function, also known as the logistic function, to map a linear combination of the input features into a range of 0 to 1. So this is what the sigmoid function looks like. So the function, as you may have seen before, is f of x equals 1 over 1 plus a mathematical constant to the negative x. This is a graph of what the sigmoid function typically looks like. As you can see here, it's an S-shaped curve where all of the y values are in between 0 and 1. As the model evaluates each data entry, the outputs will be a number between 0 and 1, which represent the probability that each data entry is in the first category, which is the cat category, or the 1 category. We use a decision boundary to determine at which point we will assign each data entry to each category. If the decision boundary is 0.5, that means that for any probabilities of 0.5 or greater, it will be in the cat category, or 1. But for any decision boundary that is less than 0.5, it will be in the not cat category, or 0. Thus, the closer the predicted value is to 1, the more likely it is to be in the cat category. Or, in other terms, that is how likely it is predicted to be a cat. If you look at our data again, you can see that in the cat or not cat category, we will have either a 0 or 1. This is where the logistic regression model will make the predictions. So each line or each data entry in this chart will be given a 0 for not a cat or 1 for a cat. Ideally, we would want to get the same results that we put into the model. So we would say that the first one is not a cat, the second one is not a cat, but the third one is a cat. So ideally, we should get 0, 0, and 1. Overall, logistic regression is a great place to start if you're looking for a supervised machine learning technique for binary classification. If you like this video, please like and subscribe. If you have any questions or want to share your thoughts about this topic, please leave a comment below.